So now that we've talked about how to run the program, let's take a look and see how you can actually implement parts of it. And I'll break this up into a couple different sections because there's lots of moving parts here. So let's start first by talking about the various fields that are defined in the EX3 class. We keep a couple of statistics that are atomic integers to keep track of the number of items that are pending between the publisher and the subscriber, which can be useful to figure out if you're getting overwhelmed. We also have a list of randomly generated integers, which could be set, of course, by command line options. We have a pair of schedulers. One can be used for the subscriber, which will be, or subscribers, because we could have multiple threads doing the subscriber role. And those will be used to process the data that's coming from the publisher. And then we have another scheduler, that's the publisher scheduler. These two schedulers can be the same scheduler if we run this in single threaded mode. And I'll show you how you can trivially do that. Or you could have one thread for the subscriber scheduler or n threads for the subscriber scheduler. And of course, the more threads you allocate for the subscriber scheduler up to roughly the number of cores on your machine, the more speed up you're likely to get. This is a good example of an embarrassingly parallel program. We also have a cool subscriber implementation called the back pressure subscriber, and that's what's used to implement the back pressure mechanism here. And then we have another interesting field called Disposables, not to be confused with the Sylvester Stallone ensemble movie. I think they were Disposables too, or Dispensables or something like that. But this is a way of keeping track of resources that need to be cleaned up, in particular, things like handles to thread pools and so on. Here's the main entry point to the program. We make a new instance of the class and we run it. So it's off to the races. And you can see how this is all going to work in a second. So if you take a look at the constructor, we have a very interesting options singleton. One of the few places that I use singletons is usually for options, just because I don't like to have to clutter my code with option global variables or option parameters. And there's a whole slew of different parameters that you can pass on the command line. You can disable and enable back pressure. You can disable and enable debugging. You can disable and enable logging. You can count you can have a count of the number of items you want to generate. You can determine the maximum value for each item. You can select the Memoizer strategy. You can select the Overflow strategy, which is how you deal with things when they come in faster than the back pressure can handle. You can determine if you want to run in parallel or not. You can set the degree of parallelism of the number of threads running for the subscribers. There's some timeout stuff, which we use for one of the cached timed Memoizers. And then there's some other stuff we use for printing things out. So I won't go through this in gory detail, but it's basically just a class that's used for all the options. And there's lots of options, as you saw when you saw how the program was run. So the next thing we do is we're going to go ahead and generate the number of random integers that was requested, either the default or what was requested on the command line, and also set the max value, which is either the default or what you set on the command line. And this function is very simple. We use the random number class in Java to generate count random integers between 0 and the max value. And I subtract count from max value to try to generate a bunch of duplicates because we want to use our Memoizer. We box these things up, converting the primitive int into an integer, and then we collect it into a list. So probably should have used reactive programming here, but I just wanted to make it simple. So we just generate a list of random integers using classic Java sequential streams. We now do some more initialization. This is actually pretty cool. We go ahead and we allocate a new publisher, saying we want this thing to run in a single thread, and we gave it the name publisher. And that's why all the logging information you saw when we ran the program all said publisher -1, because that's the first publisher thread. Then down here, we do some fancy footwork. We check to see if the parallel option has been set on the command line or whatever the default is. And if you're running in parallel, then we go ahead and we make a new scheduler, which we call subscriber, and we indicate how many of these subscriber threads we want. Say one thread, in which case the publisher and subscriber will run in producer consumer style threads, or you could have a bunch of subscriber threads, like you'd have a pool of them. And so that's what happens if you select the parallel option. You end up with parallel publisher and subscriber or subscribers. And if you don't select the parallel option, then we just make the subscriber scheduler be the same as the publisher scheduler, in which case everything runs in the same thread. We then go ahead and create a back pressure subscriber. We'll look more at that later. And then the last thing we do is we take all of these little handles we just created, publisher scheduler, subscriber scheduler, and subscriber, and we go ahead and we stick them into a composite disposables object. And we'll use that later to get rid of all these resources in one fell swoop. And it's very important to remember whenever you create new schedulers or subscribers and so on that are not ones that come as pools out of the box, like the parallel scheduler. If you say new parallel, then you have to dispose of that handle that comes back. If you use the parallel pool, then that knows how to dispose itself because those are all going to be implemented as daemon threads. All right, here's the run method. This is what we call when we want to run the tests after we've initialized things. And again, I'll give you kind of the big picture view here, and then we'll come and dive down into the details as we go into other parts of the code. So we're going to have two different versions of this program. One is going to use a Memoizer, and a Memoizer, as we'll see, is just a special cache that wraps around a function. And the way the Memoizer works is whenever you call an operation on the Memoizer, like check to see if it's prime, it'll first go and look up in a concurrent hash map to see if we already have a value associated with that key, with that prime candidate. And if so, that's the result that was pre-computed earlier when we ran it the first time. So we'll just return the value, which is the indication of whether something was prime or not. If we do not have a value associated with that key, then the Memoizer will call a method. In this case, it's the isPrime method. And the isPrime method, as you can see, goes ahead and does a brute force computation to see whether a number is prime. And if it is, it returns 0. If it's not, it returns its smallest factor. So this is kind of a clever way of being able to do this caching mechanism so that if you look something up and it's already there, you don't have to go look it up again. The next thing we're going to do is we're going to take the Memoizer we just created, and we're going to call a special helper method called time test. And we're going to pass it some interesting parameters. If you take a look at time test, this is a really cool little helper class I wrote. So time test takes in a function, and actually I take it back. It's actually a by function. You'll see why it's a by function in a second. And the by function is going to return a function to an integer. It's like a mapping function, and it's going to take in a function to an integer, and it's going to take in a string. And it's going to use this special method that times how long something takes to run. If you go take a look at this, you can see that the time run will go ahead and call the get operation on the supplier after first starting the timer and then stopping the timer, and it'll store in a map how long it took to run. So we use this to go ahead and time different operations. And this is very cool examples of behavior parameterization. And we've talked about that in other parts of the course, but it's a really valuable feature that's popular in both functional Java and reactive Java. So we're first going to go ahead and run this test. You'll see that the run test method is defined down here. We'll look at that in a second. That actually runs the test. When we're done running the Memoizer version, we get the results of that and stash it away. Then we shut down the Memoizer to clean up the resources. And then we go ahead and run the test again, except this time we're not going to memoize. So we're just going to pass in the isPrime method directly as a method reference. So this will bypass the cache and will compute the prime check for every prime candidate rather than using the cache. And if you go back and look at the results in the earlier video, using the cache speeds things up quite a bit. When we're all done, we dispose of all those disposables. The name of the movie with Sylvester Stallone was Expendables, not Disposables, but same thing. So we dispose of the disposables. We then go ahead and print the results, which will be sorted by which particular test ran most quickly. And then if we've enabled diagnostics, we do some clever printing of the results, and I'll show you that later too. Okay, so that's kind of the high-level view of what we're doing. If you come down here and look at the run test method, this is pretty neat. We print the test we're running with the count of the number of elements, number of random numbers we're going to be evaluating. We set some counters back to 0 to start out. And then we're going to define ourselves a local variable called check for prime, which is a function that takes an integer and returns a flux of prime util result objects. And we'll see what this does in a second. What this does is it uses the number that's passed in here, which is the number we're checking to see if it's prime. We go ahead and publish this to run it in a different thread altogether. This is going to be running in the subscriber thread. And keep in mind, there could be multiple of these threads. So it'll kind of decide whichever one is available next. And so we're going to go ahead and run this computation on the subscriber thread. And then what we do is we check to see if the number is prime or not. And what this does is it checks to see if it's prime. And the way it checks to see if it's prime is quite clever. It goes ahead and uses the prime checker function that's passed as a parameter, which goes and checks to see if the number is prime. And what's clever about this is that this prime checker function is either going to be the prime checker that's the memoized version, or it's the version that just the isPrime method, which does not do memoizing or caching, but the code looks exactly the same. So this is a nice example of behavior parameterization. And what this will give us back, as you can see, is a flux of results, which in this case will just have one. So now we're going to get into the real meat of this program. And I'll give you, again, the high-level view, and then we'll dive into the details in upcoming parts of this lesson. So we're first going to call this method here called publish random integers. And I'll just show you at a high level what it does. What this will do is it will take a scheduler, which could be either its own scheduler or the one that it's sharing with the subscriber or subscribers. And it will then use the create factory method. So what create does on a flux is it gives you a chance to dynamically compute the flux. So you could have sort of an arbitrary size of things you're going to create. And I'll go into this in more detail later, but we're going to either emit with back pressure or we're going to emit without back pressure. And I'll come back and show you both of those emitters in just a bit. We're also going to pass in the overflow strategy, which says what happens if the publisher goes too fast for the subscriber or subscribers. And we want this computation to run in a background thread or in its own thread, so we give it the scheduler. So what that's doing is it's running the publisher in the publisher thread pool, but it's a thread pool the size of one. And so we're going to be generating all the random numbers in the background in that publisher thread. And we're either going to generate them in one big fell swoop if we're doing it without back pressure, or we're going to do it with back pressure enabled, in which case it'll generate a few things, let the subscriber process them. Then the subscriber comes back and says, give me the next chunk. It'll generate a few more things, wait for the subscriber to process them, then get another request, and so on and so forth. So then what we're going to do, remember when I showed you what the output looked like if you turned on logging? We're going to use a very cool method called transform, and we're going to conditionally turn on logging. So if logging has been enabled, if that value is true, then we're going to go ahead and say, hey, Flux, log the results of these low-level publisher and subscriber calls. Make those things show up in log output. Otherwise, if we've disabled logging, don't do anything with logging at all. Just have the Flux return its current value. So this is a nice way of being able to conditionally do things using the transform operator. And there's also another operator called transform deferred. That's just to turn logging on and off dynamically, just a little trick to know. What's really important here, though, is the flat map operation, which is going to call check for prime. And this is going to use the flat map concurrency idiom to concurrently, maybe, check to see if each random number is prime. And I say maybe because we can set this to be single-threaded, where the publisher thread and the subscriber thread are the same thread. But if you have turned on the thing to run concurrently, then flat map will use this concurrency idiom, and it'll go ahead and do these calls in background threads. And then the final thing we do here, so we started the publisher, it's going to start publishing. We've got a way to be able to, in a different thread, perhaps check to see if a number is prime. And the last thing we have to do is call subscribe. And as you all recall, that's what starts everything going. And we'll look at subscribe in a minute. It's a very special kind of a subscriber. And the reason it's a very special kind of subscriber is because we've set it up so that all that stuff can go running off in these background threads, but the calling thread will block until all the processing is done. And it does that because we've stuck a countdown latch in that subscriber. And I'll show you what that looks like in a minute. When we're all done, we go ahead and print the results out, and then we return the prime checker, which may be modified and so on. Let's see, I've shown you publish random integers. We'll come back and look at that in more detail. Here's print results. Print results gets used to print the results out when we're done if we've turned on debugging. And this is actually very clever as well. What we're going to do here is we're going to go ahead and sort the, we're passing in a map of results. And we go ahead and we sort the map by value. And then we go ahead and print out the contents of the map. And the map is very clever because it keeps track of whether or not something is a prime number or not. And we'll talk a bit more about that. And so then we go ahead and print out the primes using the sorted map, using a take while mechanism. And then we'll show later how to print out the non-primes using the sorted map, using another flux mechanism. These are called slicing operations. And then there's just one more thing in this file that shows how to make the exit string. And that's just what you use when we print out the results to indicate whether or not there were duplicates. And of course, there are only going to be duplicates if the prime checker is an instance of a Memoizer. And in that case, we may have duplicates and we print out the number that there were. And if you go back and look at the run results, you'll see that there's often a bunch of duplicates. And this is what you can use to figure out what they were. So that's the overview of kind of the main driver program. What we're going to do in the next part of the lesson is look at some of the other pieces in more detail.